Hello and welcome to Section 1.3b. Section 1.3b, this should be short and sweet. We already talked about finding the distance between 2 points in 1.3a. You can use Pythag or you can use distance formula. So now we'll just do a quick talk about midpoints. I actually have a distance on a number line. I don't even know if we need to talk about this very first example. There's a fancy little formula that we can use in order to find the distance between 2 points on a number line when you are given the coordinates. My guess is that probably everybody is going to count the distance. If you want to be technical, you can subtract the coordinates on a number line. Notice on a number line, it's two-dimensional. You just have a coordinate for each end. So segment BE, so to find the length from B to E, so here's B over to E. The distance is whatever the distance is between -6 and 2. If you want to count it, if you want to common sense your way through it, it looks to me like segment BE is equal to 8 units. If I count from -6 up to 2, I know from 0 on down there's 6, from 0 on up there's 2, 6 plus 2 is 8. The technical way is to do -6 minus 2 and take the absolute value of it, blah, blah, blah. But I think everybody's pretty good with that. So count the distance between the values, the endpoints, I should say that. Count the distance between endpoints. Midpoint on a number line gets a little bit trickier because people forget to do the last step. So the midpoint on a number line, if I want to find the midpoint of segment BF, so I'm going to highlight BF like I did before. So here's B to F. I want to know what the midpoint is. That one's a little bit harder to just count. So what we're going to do is we're going to find the distance. So count the distance. And then, since it's midpoint, we're going to divide by 2. Midpoint is the halfway point, right? Here's the thing that people forget to do the last step. This is not the actual location. Not the actual location. You have to count from each endpoint. So let's do that. Let's make sure that you see what I'm talking about. In case you didn't notice, I do a lot of abbreviations. Abbreviate. Your notes need to be able to be read by you. So I will look to see that they're complete, but you need to be able to read them. So again, feel free to pause, rewind, stop, rewatch, whatever you need to do. Good thing before a quiz or a test, any sort of assessment, is to go back to a section of notes and maybe rewatch a piece of it. See, make sure you know what you're doing. So the distance from B to F, from -6 up to 5. If I just ask you for the distance, count the distance between them, I'm pretty sure that would be 11, right? Then to find the midpoint, I'm going to divide by 2, because that's what I said to do. Let's do midpoint equals, count the distance, divide by 2. Well, 11 divided by 2, I'm pretty sure that's a 5.5. Remember, this is not an actual location. 5.5 on the graph, on the number line, is right there. Is that the midpoint of that highlighted segment? Definitely not. What we've got to do is we've got to count from each endpoint, B and F, 5.5 units towards the center. That will be our actual midpoint. So if I start at B and I count 5.5 units, 1, 2, 3, 4, 5, and another half, that gets me right there. If I started at F and went backwards in the negative direction, I would count 1, 2, 3, 4, 5, and another half. What's the actual coordinate of that slash mark that I put on that segment? That would be what? Negative, I'll put midpoint equals -0.5, -1/2. Is it okay to have a decimal or a fraction location for a midpoint? Sure, right? Why not? It's halfway between each point. I purposely picked one that had a decimal so that we could talk about that. And I purposely picked one that had that 5.5 that was outside of that highlighted segment. So count your distance between your endpoints, divide by 2, and then remember to do the last step. It's not an actual location, it's the distance from each endpoint. It's not that hard, but sometimes you're in a rush and you forget to finish things up. All right, if we're talking about a coordinate plane, this has a nice formula. Remember how we just did distance formula in 1-3A and it had x1s and y1s? Please notice I've got x1s and y1s again. So my first point, x and y, my second point, x and y. And what I'm saying is, what's the midpoint of that segment? So before I even give you that formula, let's do this example over on the right. The midpoint of point A and B. So A is at 5, 2. 1, 2, 3, 4, 5, 2. And don't forget, please label it point A. I'm going to tell you to label, draw diagrams for everything. Don't just put a point on that graph. B is at -3, 4. Point with B. Here's my segment, and I want to know the midpoint. Now, there's going to be one in every group who says, well, I can just basically see what the midpoint is. Midpoint's probably going to be somewhere in here, right? I can make a really big dot and make it look like it. However, your teacher, me, is not going to be okay with, well, it looks like it's about at that point. I want to see how you figured out, and you definitely know where that midpoint is. So here's our formula. Midpoint. And we write it with that subscript midpoint xy because it is an xy ordered pair. It's a graph. We've got two axes, so we have to have two values for our point, an x and a y coordinate. So the first half, we take our x's, add them together, divide by 2. For the second coordinate, the y coordinate, we take our y's, add them together, and divide by 2. There's a lot of formulas to remember. Distance has subtracting in it, midpoint has adding. You need to know your formulas. I'm hoping this is all a review. So I purposely labeled these this way. Point B is on the left, point A is on the right, but it doesn't matter which one is your x's 1s and y1s and which one's 2s. So I can call this, just because it's typed out, here's x and y from my first point. Here's x and y from my second point. So the first point gets 1s, the second point gets 2s. So in this specific example, my midpoint is, really we're taking the average of our x's. So my x1 plus x2 would be 5 plus -3. y1 plus y2 would be 2 plus 4. So that means that my midpoint is going to be at 5 plus -3 is 2, divided by 2 is 1. 2 plus 4 is 6, divided by 2 is 3. So my midpoint, my actual point M for midpoint, is at 1, 3, over 1 up 3. I was pretty close on my eyeballing it, and it looked pretty good, but your teacher is going to want to see that work, not it looks like it's at 1, 3. Easy formula, just don't forget there's two parts because we need an x and a y coordinate. So this, I scrunched this onto the same page because a segment bisector is any segment, line, or plane that intersects a segment at its midpoint. So midpoint, this is crucial. So point M is the midpoint. If I drew myself a line and put a point K, I could say that line KM is a segment bisector because it bisects AB at its midpoint. So midpoint and segment bisector sort of go hand in hand because you need to know what the midpoint is in order to put a segment bisector in there. All right, so let's see. I've got a couple examples. I don't know how much we need to do on these examples. What's the distance between B, 140, and negative 200? Please notice it asks for distance, not midpoint. So if I had negative 200 and positive 140 and 0 somewhere in here, the distance between those, 340 units, right? You don't need to count every dot. You're going to common sense your way through it. How about over here, the midpoint for B of 6 and negative 5? If you need a diagram, feel free to draw a diagram. Here's 6, here's negative 5. 0 is somewhere in between them, not necessarily in the middle. Excuse me. So remember, if we're going to find the midpoint, we're going to find the distance between those 2 points, divide by 2, and then that's not an actual location, we have to count. So the distance between negative 5 and 6 just happens to be 11. 11 is not your answer every time. If we divide by 2 for the midpoint, that's a 5.5. 5.5 is like right here on my little graph. Definitely not the midpoint, right? So 5.5 units back from 6. 5.5 units in the positive direction from negative 5. What will be the midpoint for that? That's going to be a positive 0.5. Again, I purposely picked decimals just because I want to make sure you know that it's okay. You wouldn't get a decimal if you did number 4a. Don't forget, it's not an actual location. It's math. Find the coordinates of each midpoint. So let's do B for this one. If my endpoints are at negative 2, 3, and 5, 9, I don't want to graph this. You can if you want to, but I know that if I label these with x and y's, 1s and 2s, I can do the midpoint formula. So my midpoint ordered pair is going to be add up the x's and divide by 2, add up the y's and divide by 2. So negative 2 plus 5 for my x coordinate, 3 plus 9 for my y coordinate. So my midpoint's going to be at, let's see, negative 2 plus 5 is 3, divided by 2 is 1.5 or 1.5. 3 plus 9 is 12, divided by 2 is 6. So my midpoint for this set of ordered pairs is going to be at 1.5, 6. Can you have an ordered pair at 1.5 with a decimal in there, 6? Of course you can. It's directly in between 1 and 2. All right. So then we've got these little guys. It says in here to find the coordinates of the endpoint if the midpoint is known. So we're going to need to do ourselves a picture for sure. Let's do letter A this time. We've been doing all B's. So find the coordinates of D if point E is the midpoint of DF and F has coordinates of negative 5, negative 3. I need a picture. I got to picture this. Let's see. Find the coordinates of the endpoint D if E is the midpoint of DF. So I'm going to put those little congruent dashes on there, right? I know if it's a midpoint, they have to be congruent just to show that it is. And let's see, I'm going to put the ordered pairs on here. So D is what we're looking for, so that's going to be an XY. E, it says, is at negative 6, 4. And F is at negative 5, negative 3. I know I drew a horizontal line. It's not going to end up being horizontal, but what we're going to do is we are going to use our midpoint formula. So we're going to add up our x's. Oops. Add up our x's, divide by 2. Oops. x1 plus x2, struggling. y1 plus y2. But this time, when we just did this problem last time, we knew the x1 and the x2, right? We didn't know the midpoint. We've got a different unknown. We're going to divide this up into two little problems. So this would be our x2 and y2. This is our x1 and y1, and our midpoint we know. So if I think about this just in terms of two little problems, when I found the x, I did this. This is a math problem that we can do. My midpoint x value is -6. My x1 I don't know. My x2 is -5. I just took that highlighted part out of that problem and I can solve it. My guess is that most people are going to want to get rid of that 2 first. Multiply by 2. So -12 equals x1 plus -5. So I'll add 5 to both sides. So it looks like a -7 is going to be my x1. In order to find my y coordinate, we did it all in one big problem, but to find the y coordinate, we do this, right? Well, I know my answer for my y. My y midpoint is 4. My y1, according to my diagram, is what I do not know. My y2, according to my diagram, is -3. And don't forget, it's a divide by 2 in the problem. So the first thing I'm going to do is times by 2. So 8 equals y1 plus -3. So I'm going to add 3 to both sides. So y1 is equal to 11. So that means my ordered pair for point D is that x is -7, y is 11. Those guys are tricky, but think about the formula. The original formula is really easy to use. We're just putting our unknown inside the problem instead of in the answer. Last but not least, let's do a quick talk about this one. It says to find the measure of PR if Q is the midpoint of PR. I gave you a little clue when we drew that last diagram. Midpoint means what? If Q is the midpoint, what does that mean about the segments on either side? They have to be congruent, right? That's what midpoint is. It's directly in the middle of point P and point R. So if PQ is congruent to QR, notice my geometric statement, I could really easily then put that problem into an algebraic form. Substitute those values from the diagram and go ahead and solve that. When I solve that, I would get x equals something. Is that what the question asks? What's the question ask you to find? What's the measure of PR? So I'm going to have to go back after I solve for x. I'm going to have to substitute that value in to find the length of PR. So what I want you to do is to finish this problem so that we can talk about finding x and finding the length of segment PR. PR is the whole thing. I'll be interested to see what approach you take. That is it for section 1-3B. Thanks and have a fabulous day.